Today we will discuss the behavior of a charged particle in a magnetic field. I mean the trajectory or the path that is going to be traced by the charged particle when it is being sent into the magnetic field. We have a problem for this. An electron that is emitted by a heated cathode and accelerated through a potential difference of 2 kilovolt enters a region with uniform magnetic field of 0.15 Tesla. We have to find the trajectory of the electron if the field makes an angle of 30 degrees with its initial velocity. So we know the causative for the acceleration or the change in velocity that is being gained by the charged particle, that is the electron, is because of the potential difference. So that potential difference, when I multiply it with the charge E into V, I should be able to get the unit for energy, which is nothing but the equation for kinetic energy, half mv squared. I can equate this because potential difference is the causative for my acceleration. So once the particle is accelerated, it would have gained kinetic energy. If I know the mass of the particle, eventually I will be able to calculate the velocity that is being gained by the particle. So I know the value of V, nothing but for an electron is the charge 1.6 into 10 power minus 19 coulombs. Let me write the unit here. Into 2 kilovolt is nothing but 2000 volts, is equal to half into mass of the electron. Since it is told as an electron, we write mass of electron is 9.1 into 10 power minus 31 kg into V squared. On evaluating this, I will be able to find out V is equal to root of 1.6 into 10 power minus 19 into 2000 divided by 0.5 into 9.1 into 10 power minus 31. So using the calculator, I'll be able to find out 2.7 into 10 power 7 meters per second is the value of velocity. So having said that, now I know the velocity of the particle which is entering into this uniform magnetic field of 0.15 Tesla. So let me first, having said that, we will now draw the magnetic field and the angle of entry of this charged particle. So we see that the magnetic field is uniform. So I will just represent it with equally spaced lines. So vector B is equal to 0.15 Tesla and the charged particle or electron is represented by the velocity vector V, enters at an angle of 30 degrees to the field as mentioned in the problem. Now we know that when it is going to be entering by an angle, we have two components to be resolved, that is the vertical component of the velocity and the horizontal component of the velocity. Now had it entered at a right angle, we could quickly apply the right hand palm rule, which gives me, see, the thumb will give me the direction of the velocity of the charged particle or the moment of charges. The extended fingers will give me the direction of the field, and the palm, the open palm, that is which will be pointing towards the direction of the force that is going to act on the charged particle. So since here in this case it is entering at an angle, the horizontal component, as per our expression, we know that it is F is equal to Q into V cross B. The horizontal component, simplifying QVB sine 0, because it doesn't make, it's parallel. So sine 0, this part is 0. So the force acting on the particle due to the horizontal component will be 0. Only the vertical component, the force because of the vertical component will be effective on the charged particle. So that I can write it as F is equal to Q V cross B, nothing but the vertical component, which I can write as E VVB sine 90. So simplified as E VVB sine 90 is 1. Now we will have to find out the value of VV. VV, the vertical component, is nothing but, very clearly looking at the figure, is nothing but V sine 30. So VV is V sine 30 from the figure after resolution of vectors. So V is nothing but V sine 30. Now proceeding further, to evaluate the force, we have F is equal to 1.6 into 10 power minus 19 into V, the earlier value which we got 2.7 into 10 power 7 into sine 30 has got 0.5 the value. Into 0.15. So we have got the expression for force, which is nothing but 1.6 into 10 power minus 19 into V, the velocity, which is nothing but VV, the vertical component velocity, which is nothing but V sine 30, 2.7 10%, the earlier found velocity value, into sine 30 is 0.5, into the value of the field. Now this force is the force which is responsible, as I told you, by applying the right hand palm rule. The thumb extended will give you the direction of the charge particle. Here in this case, it is the vertical component of the charge particle, and the extended fingers will give you the direction of the field which I drew earlier, and the open palm will give the direction of the force that is going to act. So this force which is going to act will bring a circular trajectory onto the charge particle. You can imagine a circular trajectory into the charge particle. Now, since only out of the two components, the horizontal and vertical component, since only the vertical part is acting on the charge particle, definitely it takes a helical trajectory. You can imagine it takes a helical trajectory. So that will provide for the centripetal force VV squared, mv squared by r. So it will give you the helical trajectory whose radius will be r. So I will represent that r as the radius, which is nothing but rv. So now simplifying again mass will be the mass of the electron. So equating this, I'll get 9.1 into 10 power minus 31 into VV squared, which we already calculated as 2.7 into 10 power 7 into 0.5, the whole square, because we have got VV squared divided by radius of the trajectory that is going to be, the helical trajectory that is going to be formed. Now simplifying this expression, this part will get cancelled with one of this, and further what I get is that radius of the trajectory will be equal to 9.1 into 10 power minus 31 into 2.7 into 10 power 7 into 0.5 upon this value will be upon, let me rewrite that part, rewriting it, we get 1.6 into 10 power minus 19 into 0.15 is equal to 9.1 into 10 power minus 31 into 2.7 into 10 power 7 into 0.5 divided by RV. Now simplifying for RV, let me write it here. So RV is equal to 9.1 into 10 power minus 31 into 2.7 into 10 power 7 into 0.5 divided by 1.6 into 10 power minus 19 into 0.15. So simplifying this, we get 0.5 into 10 power minus 3 meters, or 0.5 millimeters will be the radius of the helical trajectory